Good morning. I'm Davide Brunato. I'm a member of SISSA computer staff since 1998, and I was involved in Max project as a Python expert. A summary of this talk is about a Python library that I have developed for helping XML data validation for Quantum Espresso. And at last, I describe the intentions for building a post-processing tool also for Quantum Espresso in Python. XML, Extendable Markup Language, is a markup language defined with SGML. Essentially is a data format. XML is also a language that you can use to create other languages with schemas. XML libraries implementations use three main types of AP standards. DOM, that is the World Wide Web Consortium standard, the older standard. Simple API for XML, and Element 3, that is a faster implementation and with a simpler, happy API, and is preferred often. XML schema is a widely used standard for XML data files. There are two versions. The first version is 2001, is produced in 2001, and the latter is 2012. There is backward compatibility from 1.0 and 1.1 version. The pro for XML schema is popularity, flexibility, and is definition is only on with XML based files. Versus is more complex than other XML schema standards. For Python, there are standard libraries for all the three API standards, and a powerful external library that is LXML, that is a Pythonic binding for C libraries, well-known C libraries, libxml2 and libxslt. The difference between LXML and the XML3 libraries of the standard libraries of Python is that LXML provides extended elementary APIs, and mainly it has XML validation that is not available in the standard library. XML data validation because we need a more formal XML data representation and check for Quantum Espresso input and output. To verify, the scope is to verify the products of simulation tasks. So this is the process. We have a schema, an instance, and then com'è che si fa qua? Okay. sorry. We have a schema, an instance, a validator, and the validator output if the instance is valid or not valid with the schema. For PW, that is the first program that the main program of Quantum Espresso. The problem was about converting XML input into Fortran name list input. The first problem we had. I take over about a year ago a prototype written by Giovanni Borghi for a first version of PW schema. And the first prototype uses the XML library for parsing and also for validation. So this is the approach, one script or set of scripts. So, but the problem is not in general so simple, because the main problem is to decoding the XML data, because all the data in XML is a text-based format. So each value have to be converted to a proper integer or other floating point data value or other Boolean. And so we decomposed the problem in two parts. The first is take the XML input and process with the XML decoder and translate to a Python dictionary with data values that are values in just in integer or floating point or Boolean or also strings. And then process the Python dictionary with a name list translator that we made after the first part. Oh, okay. The problem of the coding require a parse of the XML schema in a structure of with XML schema types, elements, and attributes. Also, the LXML element tree API is most useless because the class that validates the schema, that represents the schema in the LXML library, in this library, does not include the API for access XSD declarations. So it's useless because we cannot know if it's an integer, if it's a limited small integer or greater, or has numeration specific values. Also, we have not found other packages that could be used for this task. So we decided to create a new Python library for decoding the values to a dictionary, encoding probably, and after this also validating, because the difficult task is to build the structure of schema types, elements, and attributes. More than this, the new package, we also check not only the data, but also the schema. So we have meta XSD meta schema that with the meta schema you can check an XML schema like other program can do in Java, for example. Python ingredients used, advanced features of Python, like closures, generator function and methods, decorators. This is the first result, a package published at this address. The license is MIT, because we want the code can be reusable in another, as a library, or embedded in another tool without relicensing, with the possibility of relicensing. And the status for now is beta, but I think the first, at the end, the first version, a stable version, should be ready for the end of January. And now cover schema version 1.0, but there are some differences using Python features. So I think I will cover also 1.1 soon. The package is available in Python package index, compatibility Python.7 and Python 3, about 2,400 lines of code at the moment. I have tested with more than 100 test schemas or well-known schemas. If you have other schemas that you should want to try, you could contact me and I will try. This is an example of usage of this library. One import, create the schema object from a file that define, and convert. For example, there are some other APIs, and you can see that I convert this is a file with XML, all in text format, but the dictionary that I produce is as numeric values that can be converted simply to data in the scripts in other programs. At last, I talk about ideas for Python tools for Quantum Espresso. An experimental package was developed last summer for the first step. I have collected some requirements. Maybe this package should be usable as a library with specific APIs, and has to be an interface for existing Quantum Espresso tools. My proposal, after talking with specifically with Stefano Baroni and Pietro De Lugas, is to make a package that is both command line based, usable with a specific set of commands, and as a library. This is not a problem with Python, because Python has many libraries for command line parsing, and is dynamical language that you should use the same code as a library or with commands without rewrite parts, but using some different calls. And try to use the Python C interface instead F2PI, that is the NumPy translator from directly from Python to Fortran, because C interface is more manageable if you build one. Try. My conclusions. My experiments with XML and XML schema, I think that is required a systematic approach, because the schemas are very, sometimes are very complicated, and better if we have a dedicated library, deeply tested and developed alone. And mainly to support schema changes. If we don't have a library, a tested library, schema changes can block the code, the working of the code in the Quantum Espresso translations, for example, from input to name list. And with a specific library, I think is possible also to try to experiment schema-based conversion with another formats, like JSON, that is widely used. For post-QA, I think it's to consider if support Python.2.0 anymore, or use only Python 3. The approach is starting with less, small set of commands like pp or bands, for example, like sorry, vabbè, fatto così, ecco, like this. And then add other commands next. Thank you.